Welcome, everybody, as we keep diving into inverses of functions, but with restricted domains today. So, our learning objective will be able to find the inverse, inverse of a function, but I will need to restrict the domain. What does that mean? I'm going to limit the x values. So, for example, if I have something like this, I'm going to only pick one side. For example, I'm going to say, hey, I want this red side, or hey, I want this left side. And there's a way of saying, hey, I want this part of it. All right. So here's the question. Why would we need to restrict the domain of a function for its inverse? Let's continue. Reminder directions. So we're going to rewrite the function as an equation relating x with y or y with x. So we're going to exchange or switch out the x and y, and then we're going to solve for y. Replace y with, the whichever one we're doing, like the inverse of x, inverse of f, and then graph both to determine the differences. So simple example of inverses with restricted domains. We need to find the inverse of the following function. F of x is equal to x squared. Well, that seems pretty nice. We're going to say, hey, y is equal to x squared. Next part, switch them out. And so we have x is equal to y squared. And we haven't solved for y. What number is with y on the same side? There's only a number with y right there. Now, is it adding, subtracting, multiplying, or dividing? Or is it an exponent or a power? So it's actually an exponent of 2. It is squaring. And the opposite of squaring is going to be square rooting. So in order to get rid of this squared, I'm going to find the square root. And so I have y is equal to the square root of x, positive, negative. Because it's going to be both like, hey, let's say, hey, let's input 4. If we input 4 into this function, then the square root of 4 is equal to both positive 2, 2 times 2 equals 2, 4, and negative 2. Negative 2 times negative 2 equals 4. So I have two different answers right here. One input has two answers. Hey, wait a second there. What is the definition of a function? All right, let's go on in 3, 2, 1. All right, guys, so here we go. When I graph f of x is equal to x squared, I get this graph. It's going to go forever up and forever to the left and right. Now, when I graph the inverse of this, the square root of x, it gives me like a slight problem right here. I actually in order to graph this, I had to say, hey, positive x squared. So y is equal to positive x squared. And my green one right here is y equals negative x squared. Because here's the definition of a function. A function is where every input has only one what? One output. And remember, we're using what type of line test? We're doing the vertical line test. That proves whether it's a function or not. So here's the question. Why is f of x a function? And why is the inverse of f of x not a function? 3, 2, 1. So you could have written, hey, every input has an output and it passes the vertical line test, but the inverse does not because it doesn't pass the vertical line test. It touches more than once. touches here and here. Now there's a horrible vertical line, but you get the idea. So we come to the idea of, hey, we're going to need to restrict the domain. So if the original function passes the vertical line test, but fails the horizontal one, so if we're looking at this, it passes the vertical, but it doesn't pass the horizontal line test, then we will restrict the domain. So, hey, let's review the original graph. So here's our original graph. If we look at it, we can understand that it's not going to pass the horizontal line test right here. Now, if we need to, we could take the graph and flip it around. And this is what it should kind of look like. So we already know that, hey, look, there's a part right here that right here, there's areas where it's going to have two points at this point. So anything above this way, we can either have this x values going this way, or we could have the x values going the opposite way, but we can't have both. That's this part right here. I'm drawing this. So I can either say, hey, I want you to be, okay, give me a second. So I either want you to go into negative infinity starting from 0. I'm going to restrict it to going to the left, or I'm going to restrict it going to the right. So I'd like, hey, I want going to the right. I want to start at 0, and I want you to go to positive infinity. What does this look like? Well, let's show what happens. So give me a second. In 3, 2, I'm going to pop it up, 1. So you can see that I have my x squared right here in blue. I have it highlighted right here, x squared. And then this part right here, this green, I'm going to have to restrict the domain to be less than 0 right here in order to get this domain right here. Now, let me show you the other one. So if I was to restrict it to being the domain of the original to being 0 or more to infinity, we would get this blue y is equal to the square root of positive x right here. And so this. Now, in either case, if we draw in y equals x, we can see, hey, look, there is a relation where it is flipped over y equals x. So this is y equals x. Do we need to know it? Nah, but it's right there. So this guy right here would be, this green one right here, would be y equals negative radical x. All right, guys. So let's try one more. I'm going to put up the work. I want you to try to do it, and then I'm going to put up the answer. All right, here we go in 5, 4, 3, 2, 1. Try it yourself. All right, guys. So it's at this point you might be like, oh my goodness, what do I need to do? Well, if you remember, we can do this thing called completing the square, where we're going to put our quadratic and we're going to try to get it by itself. So I see I have y squared plus 2y is equal to x minus 4. So now I'm going to go, okay, I'm going to do half of b, and then I'm going to square it because I'm completing the square. This is kind of using the area model, but like in our heads right now. So if I find half of 2 and square it, I'm going to get plus 1. So I can add 1 to both sides right now. What am I doing? Okay, let's write it out. I have x minus 3. I get this by itself. And then this part right here would actually be y plus 1 times y plus 1, or y plus 1 squared. I can take off this part right here. Now, why is that important? It's important because I want to be able to take this and solve for it. So I'm going to take this x minus 3, and I need to get y by itself. I can't have it with anything else. So I have this y plus 1 squared. Now, what is the opposite of squaring? Square rooting. So I'm going to get x minus 3, the square root of that is equal to y plus 1. So I'm going to get two different answers here. So I'm going to switch it back to y plus 1 is equal to square root x minus 3. And I'm going to get plus or minus. Now, I didn't want to solve for y plus 1. I want to solve for y. So I'm going to move this minus 1 to the other side. Cancel this out. So now I have net minus 1. So I'm going to have y is equal to negative 1 plus or minus the square root of x minus 3. Now this will be two different results right here. Now it's actually nice. I'm either going to get y is equal to negative 1 plus the square root of x minus 3, or I'm going to get y is equal to negative 1 minus the square root of x minus 3, because I'm trying to make it so that I do not have the on the side parabola, because it's not a function. Let's show you in 3, 2, 1. So, because of g of x fails the horizontal line test, the inverse is not a function. We will need to restrict the domain of g of x. We're going to look for the portion of the graph that is 1 to 1. So it can only have one input to one output. So we actually have two ways of doing it. I have it right here. I'm going to put both of these into the equation, and I'm going to show you what it looks like. All right, here we go. All right, guys, here's our graphs. So here's our original right here, but we can't actually graph it because it's not a function. So if we look right here, we can restrict the domain. So we know that if we restrict the domain at, give me 1 second. Nope, right here. If we restrict the domain all the way right here, this is halfway between negative 2 and 0. This is negative 1. If I want to, for the most part, if I want to have this positive part going up right here, I'm going to say, hey, I want you to begin at negative 1. Restrict it. Do not go past this negative 1. And I want you to take the domain and take it to infinity. And what does that mean? That means I don't want this. I just want it from here this way. That gives me this right here. The same thing applies right here. Let's say I want from negative 1 right here. I don't want this part. So I'm going to say, hey, I want you at most go to negative 1, and I want you to go to negative infinity. Use all that data. So this side would be this negative 1 plus the square root of x minus 3. And this one would be, the inverse would equal negative 1 minus the square root of x minus 3. So if we wanted to plug it in, that's what it would look like. We could restrict the domain however you want. Either, hey, I only want the top part, or I only want the bottom part. In either way, this is how you're going to set yourself up. All right, guys, last couple questions. Here we go. What is the definition of the function? And what did we have to do to g of x to make sure that its inverse was a function? All right, guys. Hope you guys have a wonderful day. And here is a simple smiley. If you want a non-simple smiley, here you go. It is the number 5. And there he is. All right, guys. Have a good one. Bye.